Hello and welcome to this lesson on the UI components of cards and the useful recycler view. In this lesson, we'll go through an overview of these components and their capabilities and look at some examples in Android Studio of implementing them. The card component in Android is meant to visually represent a physical paper card like an index card for taking notes. The component was actually previewed in Android prior to Material Design and outlines some aspects of the key components of tangible surfaces, print-like design, authentic motion, and adaptive design before the official release of Material Design Guidelines and Standards. The class CardView in the Android support library is the widget implementation of the Card UI component and can be utilized in any version of Android complying with the V7 support library parameters. The card view uses the elevation property on Android Lollipop API 21 for shadows and falls back to a custom shadow implementation on older versions of Android. The card view implementation is a derivation of the frame layout class, utilizing the lightweight implementation of the frame layout for a light and responsive UI component. Note that if you specify exact dimensions for the card view, because of the shadows, its content area will be different between platforms before Android Lollipop and after Android Lollipop. By using API version-specific resource values, you can avoid these changes. Alternatively, if you want a card view to add inner padding on platforms Lollipop and after, you can set the setUseCompat padding boolean to true. To change a card view's elevation in a backward compatible way, use the setCardElevation method. Card views will use Elevation API on Lollipop, and before Lollipop, they will change the shadow size accordingly. Cards are commonly presented to the user inside of a list view, presenting a list of different cards. One example of this is in the Google Now application, where the information is presented in a list of cards. This can also be implemented in the newer Recycler view for optimized performance. We can also see here in this image where a list of cards form a travel stream example application, as shown here with the images and other card information. The list view class, which we have previously covered, was made available since API 1, and although some additions and changes have been made to it, like the addition of methods for accessibility, it has remained mostly unchanged. The list view was extensively used in Android development, and its usage and developers' requirements for it have changed greatly over time. This has helped facilitate the reason for creating the Recycler View class. The Recycler View class also solves some of the list view and other similar views pitfalls when it comes to optimizing the recycling and memory management of their children views. Since user interaction feedback is immensely important, the scrolling action and feedback of items was greatly improved in the Recycler view. Previously, in the list view for instance, when the data of a list view is changed by another element, the list view would need to be notified of this event so that it could reconstitute its children views. This action is no longer required for the Recycler view. One of the important aspects of material design is meaningful animations. The Recycler view brings many convenience and built-in methods for adding animations easily to our lists and list items, whether it be for adding an animation for the removal of an existing item or adding an animation for the addition of a new item to the list. There are several components and classes that constitute the full Recycler View API. Some of these classes are the Recycler View itself. This provides a flexible view for providing a limited window into a large data set, this data being the content of the list we would like to present or other data sets. For the Recycler View, we will need to specify an adapter to supply this data. The adapter will need to extend the Recycler View.adapter class. This is the base class for adapters for the Recycler View. The adapter will provide a binding from an app-specific dataset to the views that are displayed within the Recycler View. The view holder describes an item view and metadata about its place within the Recycler View. Recycler.adapter implementations should also implement a subclass of the viewholder class and add fields for caching potentially expensive find view by ID results. The view holders belong to the adapter. Adapters should feel free to use their own custom view holder implementations to store data that makes binding view content easier. Implementation should assume that the individual item views will hold strong reference to the view holder object and that the recycler view instances may hold strong references to extra off-screen item views for caching purposes. A layout manager is responsible for measuring and positioning item views within a recycler view, as well as determining the policy for when to recycle item views that are no longer visible to the user. By changing the layout manager, a recycler view can be used to implement a standard vertically scrolling list, a uniform grid, staggered grids, horizontally scrolling collections, and more. Several stock layout managers are provided for general use. An item decoration allows the application to add a special drawing and layout offset to specific item views from the adapter's dataset. This can be useful for drawing dividers between items, highlights, visually grouping boundaries, and more. All item decorations are drawn in the order they were added before the item views. Finally, the Item Animator class. This class defines the animations that take place on items as changes are made to the adapter. Subclasses of Item Animator can be used to implement custom animations for actions on viewholder items. The recycler view will manage retaining these items while they're being animated, but implementations must call the appropriate starting and finishing methods when each item animation is being started and ended. Now let's jump over to Android Studio and see implementations of these components in Android code. In order to illustrate using cards and a recycler view in Android, we have created a simple demo application that will show a list of 45 cards with generic dummy data listed in a list view-like recycler view. In order to utilize the card view and recycler view classes, we need to import some dependencies from Android support libraries. We can easily add them to our module by accessing the module settings, by right-clicking on the module and selecting the module settings option for opening the module settings. Then going over to our dependency tab. We see here we have already added the card view and recycler view libraries to our dependencies. We can easily add dependencies by clicking the plus button, selecting library dependency, and searching for the dependency we would like to add to our project build. Now let's take a look at the main XML for this application. We see in the main XML layout for our application, we have a simple relative layout with a nested support library recycler view. Since we have added that dependency, we can now list the recycler view on our XML and have it dynamically loaded to the content of our activity. In this case, the recycler view has the ID RV dummy cards and width and height to match parent. Now let's jump over to our activity Java code and see how this layout is loaded and other operations are run. We see in our main activity that we set our content as usual, and then we grab the recycler view in the same fashion we would grab any other view from our layout. We see here that we set the param for fixed size for our recycler view to true, which will optimize the performance for our recycler view. Please note that this should only be set to true in cases where the recycler view has a fixed size and will not be resized during user interaction. We then set a linear layout manager as a layout manager for this recycler view, and an adapter of the custom class dummy card adapter. Let's take a look at that adapter class now and see how it implements the desired UI. Our dummy card adapter class extends the recycler view adapter class with a view holder type of card view holder, which we will see in a moment. It has the member n num cards, which is the number of cards we pass in the constructor. In the callback for onCreateViewHolder, we create our viewholder from the layout card view and create a new card view holder object from the linear layout and then return the card view holder. Let's take a look at the XML for our card view XML now. Our card view XML layout has a card view widget from our support library with an embedded text view, all within a linear layout. We will write objects to this text view in runtime to distinguish between items in our dummy list of card views. Now let's go back to our Java code. We see that in our onBindViewHolder method callback, we need to prepare the object at position I with the relevant content. We call a convenience method of setText on our cardViewHolder custom class. with an int position. We also see in the method callback for getItemCount that we return the integer of the mnum cards as we received in the constructor. Now let's take a look at the inline defined custom class of cardViewHolder. We see that the cardViewHolder has one text view as a member of the class. When the constructor is called, we grab this text view from the layout which is inflated for us and pass in the constructor. In the setText method we called from the adapter previously, we see that the text "this is card" and a number that is passed as the integer is posted to this text view. Now let's run this application and see the results in the emulator. We see even when running in this emulator, which is emulating the version of API 18 for Android, we still have the desired recycler view in Cards UI listed as a list. We can see that the cards are displayed similar to if we had a list view, but now with the optimized UI and management of the recycler view. Thank you for joining us in this lesson on cards, card views, and the recycler view in Android. Join us in our next lesson where we'll take a look at notifications in Android.